we are still discussing circuit switch network, and we have discussed about space switch, time switch, advantage of space and time switch, what are the difference between them. So, we have in the last class we have started discussing about maybe there is a combination that we can do. So, which is the space time switch. So, this particular class will be covering this combination of space time switch, how they can be combined and what is the effective features of them and how do I design a space time switch. So, that is something which we will be preoccupied with. Okay. So, we have already talked about this this time switch management or time switch interchange unit. So, which is essential part of time switching. So, now what we are trying to depict over here in this diagram, it is a time switch space switch. So, basically first portion of the switch, which is this part. So, that is the series of time switches followed by a space stage. So, we are like earlier we have done 3 stage of space switching. Now, we are actually making stages, but it is a not homogeneous stage, it is a heterogeneous stage of switching. So, some stages are time switch, some stages are space switch. Means our next discussion will be preoccupied with this kind of switching architecture. So, where we will be combining the space and time switch. We have already seen there are some advantages. Time switch, if we want to make it multi-stage, then probably the advantage was it every TSM or TSI it goes through, there will be 125 microsecond delay, and there is a restriction of the speed also, we have seen that. And space switch, if we give too many space switches, then the stray capacitance effect as well as the switch complexity goes means it does not happen to be scalable. So, that is why we are trying to actually combine these two, time and space switch, and we will try to see how do we actually do switching through this. Okay. So, this is a typical architecture of a TS switch. Okay. So, the first stage is time switch, second stage is space switch. So, how does this operate? So, what it is done, let's try to give one example of this one. So, we'll come back to this later on. Let's try to do, let us try to see. Let us take an example of four cross 4 switch. Okay. So, basically there is a multiplexer, and multiplexer has only 2 input. So, basically as you can see over here in a particular frame. So, I am just showing this frame, this will be of 125 microsecond, we have already seen that. As many we put over here input, that many slots will be coming over here. So, that is the slot size in terms of means every slot is occupying 1 byte. Okay. So, that is PCM encoded voice, that will be means one sample of that represented by PCM encoded voice sample. So, 8 bit that will be occupied over there, and this frame is repeated. So, it is the 125 microsecond we are showing. We will assume over here, of course, that is a very important criteria that we will be also discussing, that things are all synchronized. So, at the input of the switch, whatever is coming, all these frames are somehow synchronized, otherwise the switching will not be happening. So, that is something we will be trying to appreciate over here, and then we will see how to solve that. Means it might be that 2 of these inputs are coming from different location. So, how do I guarantee that their means frames will be synchronized, their clocks will be synchronized. So, those synchronization issue we will talk about that later on. Right now, we will assume that they are synchronized. That means, these frame boundaries are perfectly synchronized. So, they exactly come at the same this one, the clocks are synchronized. So, the frame durations are all synchronized. Okay. So, this is what we will be assuming. Now, this TSI, what it can do? At the output, it can swap these things. So, initially what will be happening? Over here data from 1 will be there, over here data from 2 will be there. Okay. So, that is how the data will be occupied. Similar thing will be happening over here. So, data from 3 and data from 4. Okay. So, this is how it generally happens, because multiplexer will be doing that. The first one it will put in the first slot, second one it will put in the second slot, and so on. It will keep on repeating at every 125 microsecond. So, this TSI can actually swap this. So, that is the functionality of a TSI. TSI can actually do this swapping. So, it can keep this sequence. So, that is one of the switching, that I do not swap anything. So, basically I want to keep that thing intact, but I can also swap. 2's data I can put in 1 and 1's data similarly I can put in 2. Similarly 3 and 4 I can swap, or I can choose not to swap. So, any of those options I can do at the output of TSI. So, followed by this TSI, what we will be doing, we will be putting a space switch of 2 cross 2. So, basically I need a 4 cross 4 switch, but I am actually eventually doing it because of the time switch. Now, I can go away with 2 cross 2, and because it is all multiplex. So, I can demultiplex it, and finally, I get an output of 4 cross 4. So, this is 1 dash, 2 dash, 3 dash and 4 dash. Okay. Now, think about this switch. So, let us say I want to do a connectivity from 1 to, let us say 4 dash, I want to make a connectivity. Okay. So, 1 to 4 dash I wish to do. Now, let us try to see what will be happening over here. What should I do? So, if I have to connect 1 to 4 dash, what are the options I have? So, first over here I have to decide, should I do a time swapping or not? I will come back to that, should I decide that. Okay. So, this data 1 should come out from this 4. So, for that, first of all, space switch, let us try to see what kind of connectivity I should give. Definitely, because if 1's data that is coming over here, that has to be connected to 4, which is coming out from here. So, I have to give this connectivity. So, space switch connectivity must be like this. Okay. So, now let us try to see whether 1's data can come to 4. So, think about over here this time slot, whichever data comes over here in this slot, that must be coming out from 4 dash. So, if I have to bring that data from 1 over here, it must be over here, that data of 1 must be over here. So, how I can bring that over here? Because over here the data was in the first slot. So, I must swap it. So, this is where I get the swapping decision. If I was connecting instead 1 to 3 dash, then I could not have swapped. I could have kept 1's data in the first slot only. In the time slot interchange, I do not swap anything, and then do the space switching like this. It will be 1's data will be appearing in the first slot, and that data will be coming out from 3 dash. But because I am doing this switching 1 to 4 dash, so it is absolutely essential that at the time slot interchange I swap the data. So, 1's data comes over here. Now, this connectivity should be there. Now, if you carefully see that, let us say 2, that data from 2, now I add this. So, this is not my switching, 1 to 4 dash I want to connect. Now, 2's data I want to connect it to, let us say 1 dash. Okay. So, 2's data must go to 1 dash means this. So, that switch connectivity must be like this, okay, because 2's data will be coming over here, wherever it is in time slot interchange, it will be connected to space switch in this particular port. Okay. So, and 2 data must go to 1 dash, so therefore, it must be connected to this port also. So, therefore, the switch connectivity should be like this. Okay. And 2's data 1 dash, is that a valid option? Because now 2's data will be over here, and whenever I do this switching, 2's data comes over here, and that data will be eventually, because it is in the first slot. So, it will come out over here. So, this is possible. But now you might be asking, look at the space switch configuration. Simultaneously, we have a space switch configuration which makes the connectivity, let us say this is input 1 of space switch, So, let me erase this part. Okay. So, that is input 1 of space switch, this is input 2 of space switch. So, what is happening, space switch, and this is output 1 and this is output 2. So, space switch configuration, if you try to see, input 1 to connectivity output 1, that is required for this connection, and also input 1 to output 2, that is required for this connection. So, simultaneously space switch has to be connected in 2 different places. That is a danger, that we have never done. Earlier the switch connectivity was always giving to one port, then only the switching was happening. Now, the space switch gets confused. Is it so? Probably not, there is a solution. If you carefully see within the time slot, if you now see, if the space switch also, if I just consider within this time slot, in the first time slot and there is second time slot, in the first time slot space switch must be connected. So, first data is 2. So, first time slot space switch must be having this connectivity. So, over here it should be I1 to O2. In the second slot, okay, sorry, that's wrong. I should not have done that. So, if you see the first slot means this data from 2. So, that connectivity is this one, okay, I1 to output 1. In the second slot is this data, okay. So, that connectivity is this one. So, second slot only I need I1 to O2 connectivity. So, that means now this space switch has at different time slots different configuration. Whenever I do space time switching, the space switch configuration also within the 125 microsecond, there are multiple slots, at every slot different configuration will be required. Okay. So, that is something you have to keep in mind. Okay. So, that is the extra thing that you will have to do, that means within a particular time slot or within a particular 125 microsecond slot, you have multiple slots and every slot there is a corresponding switch configuration and you have to keep on doing that. Remember, this particular configuration will be keep on repeating in the next slot and next slot. So, every 125 microsecond this particular configuration will be repeated. So, if I put these configurations, then this will be repeated in every 125 microsecond. So, corresponding every slot, these kind of configuration has to be put in. Okay. So, that is what you will have to do in a space, means time and space switch. So, this is called a TS switch and this is how TS switch is being realized. So, basically in TS switch you might have an option of time switching, is it, that depends on where at the output port you have to go. So, you have to decide it the way I was deciding. So, first you try to see, should I require a time switching, because it depends on at the output port where you want this one to go, and then accordingly you have to see whether there is a space switch requirement and in what slot it is coming to the space switch. So, accordingly you put at that particular slot a particular space switch configuration. Okay. This is what you will have to do. So, generally these are all done automatically. So, you will have to do this auto reconfiguration. So, for auto reconfiguration what you need is kind of amount of memory that you will be requiring. So, now let us try to see what is the overall memory that you will be requiring. So, now I will generalize it. So, let us say there are C number of slots over here, okay, and there are n input ports and n output ports. So, overall the switch dimension, as you can see, it is a NC cross NC. Okay. So, that kind of switch dimension. So, now you can see by just making a space switch of n cross n, of course, this n cross n again you can do multi-stage space switching to save some of the switching port, you can do that. But with the n cross n switch, because of this time switching, now I have a NC cross NC switching. Okay. So, I can actually enhance the dimension of switching by just doing this combination space and time switching. So, now with the n cross n space switching, and if I have C multiplex stream, then NC cross NC switching I have. Over here it was this space switch was 2 cross 2. So, my n value was 2. C value was 2. So, that is why NC cross NC, that means 2 into 2 4 cross 4 switch I have realized. So, 4 input port, 4 output port. With the 2 cross 2 space switch I have now realized 4 cross 4 switch. Okay. So, similarly in general this will be the case. Now, let us try to see how much control information I need. Okay. So, what are the control things we need? That means the memory that we need. In the TSI we need this memory of data storage and we need the memory storage, okay, or the control bit storage. So, let us try to see for a C, this is a TSI is a C cross C switch. So, for that we have already calculated what should be the amount of data requirement. So, that is C amount of data has to be stored and each one of them are 8 bit long. So, C into 8 amount of data storage is required, plus there is a control storage. So, C number of control and each one of them are having log 2 C, this is something we have already calculated. So, this is the requirement of every TSI. How many TSIs are there? So, as many number of input ports to the space switch are there, that many TSI I have to put at the input. So, n number of such TSIs will be there. Okay. So, these many control bits or memory bits are required for the entire first stage of time switch. Okay. Now, let us try to see how many control bits are required for the space switch. So, I have a space switch of n cross n, right. In a n cross n switch, you remember, because it is a symmetric switch. So, whether we do input associated or output associated, it does not matter, the amount of this multiplexer or demultiplexer control that are required was n log 2 n, because it is a symmetric. So, it does not matter whether input associated or output associated, will be always getting this number. So, for this space switch I need n log 2 n number of control bits which has to be stored. Now, because of C time slots, you require those control bits for every C instance or C every slot. There are C number of slots, for every slot these many control logics are required. So, therefore, C into this many control logic will be required for the space switching. So, that should be the memory requirement of the switch, M switch. It is very simple calculation. So, whenever you do this, you will be able to see that how much memory bits are required. So, this particular portion comes out from the TSI part or time switch part, and this particular portion comes out from the space switch portion. This is exactly what happens in our space switch time, means space time switching. Okay. So, I think we have now understood this part. Now, we will make it more like that Clause's argument, 3 stage switching. Okay. So, we have just understood how to actually combine time and space switch, but this is probably not the most interesting switching that we can see over here. This might have restriction. Okay. So, we will try to see, this might have blocking. So, that is something which we will be discussing next. So, therefore, we need to actually again come up with some kind of 3 stage switching where there are enough sharing, so that we have a better switch design. So, let us try to see a particular combination of 3 stage switching by this time and space switch. So, that should be our next target. So, what now we will be doing? We will be doing 2 combination. One is space time space switching, okay, and the other one is TST switching. So, basically it is a 3 stage switch, as you can see already, that is stage 1, that is stage 2 and that is stage 3, or over here this is stage 1, stage 2 and stage 3. Okay. So, it depends on what do you put. They have to be symmetric in nature. You have seen also in 3 stage or 5 stage Clause switches, you have seen that they are symmetric. So, it is also a multi stage switching. So, we will be doing symmetric switching over here. So, either both side space or both side time. middle portion is space switching. So, one of them will be doing. Okay. So, if I do this kind of switching, what will be happening? Of course, we will be requiring less amount of space switching. Okay. So, that is one advantage that we will be getting over here if we do this. Okay. But the problem is, if I do that, then because there are two time switches, so always it will be having 2 into 125 microsecond delay, overall delay, or 250 microsecond of delay. So, every switch elements of this kind of configuration will be having 250 microsecond delay, whereas if I do that, I will be only getting 125 microsecond delay. But of course, because there are two space switches, so the switch will be more bulky and more number of switching elements has to be required. So, this is the trade off that we will be trying to do. So, let us try to understand how again we can talk about this blocking probability of the switches, how do we design a strictly non-blocking switch of this kind of configuration, how do we design a rearrangeably non-blocking switch, or how do we actually go about doing some amount of blocking or allowing some controlled amount of blocking the way we have done for 3 or 5 stage switches. So, corresponding Lee's graph if we can talk about, because that is part of the designing. We want to actually reduce the number of elements that are put forward for switch designing, so that we have cost advantage. Of course, we will have this stray capacitance that will be lesser, we will have less amount of memory requirement, probably the switching speed will be adjustable, we can scale the switch. So, all those due to all those things we will be probably trying to design the way we have done it for space switch alone. Okay. So, let us take one example. Let us take the first TST switch. Okay. So, we will take a TST switch. I will again give an example of 4x4 switch. Okay. So, let us try to see how do I do a TST switch. Okay. So, basically what we will be doing, it is initially time stage. So, it will be followed by a multiplexer going to a TSI. It is 4x4 switch with a space switch requirement of 2x2. So, I am again doing same thing. Now, that gets into a, let me provide some space. So, this is a 2x2 space switch. Only difference is it again goes to a TSI. Okay. So, now let us try to see how do I do a switching and how do I make it a strictly non-blocking one. Okay. First, what I will do? I will do the general regular switching, and then you will probably means get the appreciation of blocking that will be coming to this switch. Okay. So, let us say again what is happening, if you see this middle part, this ports, okay, that is where up to that it is all separated, right. So, that is where probably there will be a sharing which will be happening. So, we will try to appreciate that part where exactly the sharing is coming up, we will see those things, but that is probably where things will be getting shared. Okay. So, this middle part. Okay. So, now let us try to give connectivity, let us see whether blocking condition comes into picture. So, when we talk about this blocking, if you remember this clause particular argument. So, you had something over here, middle there were some stages, k stages, and each of this stage was getting shared. among the input and output. So, what we were trying to see is from here there are multiple inputs that are coming, and at a particular target node there are multiple outputs. So, suppose all these are already occupied, that means some connectivities are there, and this last one is trying to connect to the last element. So, similar condition will be trying to create. So, let us say from 2 to 2 dash is my target at this one, my 1 is already occupied. Remember, the clause argument was 1 was occupied, but it was only occupying the input portion, output it was going to some other block. So, it was not coming to the same block, and 1 dash also is occupied, but not coming from here, it is coming from some other place. So, that is the kind of thing we will be putting to appreciate the blocking. So, let us first see, suppose I have already a regular connectivity 1 to let us say it is 4 dash. Okay. So, 1 to, because 2 to 2 dash I want to connect. So, think about this argument, 2 to 2 dash I am trying to give connectivity, whereas these two are already occupied. So, I have to search the blocking condition, that when these two are already occupied, in the worst case scenario, when 2 to 2 dash I have to give connectivity, but I am unable, that is when the blocking will be happening. So, when the worst case situation happens according to clause argument, if this 1 is already occupied, but not going to this one, because then things will be shared. So, 1 is going to some other place. So, 1 to 4 dash we have taken, and this 1 dash is also occupied, let us say 3 is giving connectivity to 1 dash. So, from some other block it is coming to 1 dash. So, let us first make this connectivity, because these are the past connections which are already there. So, let us make this connectivity. So, initially let us say if I have 1 to 4 dash, this connectivity I will have to give. Now, if you see, I have added flexibility. So, let me put all those synchronized slots. So, there are 2 slots. So, everywhere I have those synchronized slots. So, they are initially free, nobody is connected. So, I will be putting my connectivity. So, everywhere I will put this. Remember, I only have restriction at this input and at this output. So, if 1 has to connect to 4 dash, that means 1's data will be coming over here. I have no control over this. So, because this is being fed over here, that must be coming in the first slot. So, at this instance I have no control. I have a control after TSI. So, over here I can do switching, and I also have a control over here. Okay. So, 1 is coming over here, and then I want to put him to 4 dash. So, that means that should come over here, this 1's data must be coming over here, that I do not have a control, because if I have to switch it to 4 dash, I have to put it in the second slot, there is no other option. Okay. Now, if you see this connectivity I have to give. So, therefore, already I can see, of course, the switch also will have a slotted option. Okay. So, in different slot I can do different reconfiguration of the space switch also. So, now I have two options, as you can see, one is in the first slot and over here one is in the second slot. So, what I have to do is I have to flip it. So, this flipping can be done either over here in this TSI or over here. Okay. So, that is my decision, I can do anything. Okay. So, I do not have to, because I have now 2 stages of time switching. Earlier that was not the case, I was only having only TS switch, only one option I was having. So, I had to switch it at the beginning wherever I get chance. So, that is why that was more restrictive. Over here I have the flexibility, I can choose to put it over here. So, suppose I choose that, then what happens, this 1's data comes in the first slot. So, definitely, because space switch cannot do time swapping. So, I have to do this switching, and over here only 1's data will be coming. So, basically I have choose not to swap in the first time slot interchange, and then the space switching configuration has to be like this. So, basically if I say input 1, input 2, output 1, output 2. So, basically space switch in the first time instance. So, this is the first time instance, I have to do a cross switching. That means, I have to give a connectivity 1 to 2. at this first instance, that I have to do, otherwise that particular data will not be coming. And in the TSI I will have to do a swapping in the second TSI, that is something I will have to do. Now, because of this configuration, because of this decision, I have already decided a particular switching. Okay. So, what I will now do, I will try to see how do I give this next connectivity. So, suppose these connections are coming in order. So, 1 to 4 dash request first came, I did this switching. Now, the next connection 3 to 1 dash, that is coming. Okay. So, how do I do this switching? Now, from 3 again I have no choice, this will come over here. So, this is 3's data which will be coming over here. Okay. And 3 to 1 dash I will have to put. So, it must be over here. Okay. So, now what I can do? What I have told is something like this. I might actually choose to swap it, I might not choose to swap it. So, suppose I decide to swap it, okay, because this is at the beginning, as long as I can do things, I will be actually taking my decision. Okay. So, first I do a swapping. Okay. So, I do a swapping. So, data for 3 comes over here. Now, after swapping this swapping, what will be happening? It is coming in the third slot, remember. Okay. Now, I have to put it over here. So, I have to do this switching. So, data from 3 comes over here. Okay. So, data from 3 comes over here. Now, I have to do another swapping, because 3 has to come over here, then only I will be getting at 1 dash. So, I do a swapping. So, now the switch configuration is at the second instance I have to do this. So, again 2 to 1, that means the switch can be either in cross state or bar state. So, it has to be cross connected. So, that one input to one output mapping is being done. So, input to output mapping always have to be 1 to 1 in a space switch, otherwise there will be confusion. So, there will be data collision. So, you do not want to do that. So, therefore, this is all right. I put at the second this one 2 to 1 configuration. So, all this is fine. Now, in the next class what we will try to see, once I have done this, now if I try to give that 2 to 2 dash connectivity, you will see that there will be a blocking scenario. We will talk about that blocking scenario. We will also talk about how we can make it rearrangeably non-blocking. So, that is something we will talk about, and we will also talk about additional changes that we will have to do in this switch configuration, so that we get a strict non-blocking. So, which comes from clause argument again, we will talk about that in the next class.